speed equals distance over time. It's simple. So why do people still keep messing this up? It's because they start calculating before they even know what they're solving for. I'm going to walk you through a speed, distance, time system so you know exactly what to do and what traps to avoid. My name's Farhan, I'm a junior doctor, and I've helped over 100 students get into medicine and dentistry across Australia. And in this video, you're going to learn how to use the speed, distance, time triangle for basically any of these questions. So here it is. It's basically a triangle to help you remember the formulas for calculating speed, distance, time. So the way I want you to view this triangle is that this horizontal line here is a big division line. And then this vertical line here is a multiplication. So what it ends up looking like is, if we want to solve for speed, that looks like distance over time. So speed equals distance over time. Whereas if you want to find time, what that looks like is distance over speed. Whereas if you want to find distance, then it's speed multiplied by time. So if you remember this triangle, you are never ever going to forget those formulas. Now, if your brain just tends to work more with formulas than it does images like this, then here's the formulas in front of you. And really, you only need to remember one of them, which is speed equals distance over time, or any one of these you choose, because these that you see here are just versions of this. If you algebraically transpose to express the formula in terms of D, this is what you're going to get. In terms of T, this is what you're going to get. So you actually really just need to know speed equals distance over time, and then you'll be set for the rest of these questions. The rest of it is applying this particular concept and avoiding some common traps we fall into. So what are those traps? Number one is conversions between units. The UCAT questions love to blend between kilometers and miles, so just look out for that. And next is going to be converting between kilometers per hour and meters per second. So while you can do that just manually if you wanted to by, say, converting your kilometers into meters and then converting your hours into seconds and then doing the calculation, that just saps up a lot of time, and you want to be able to save time wherever you can. So an easy way to convert between kilometers per hour and meters per second is to divide by 3.6. If you want to go the other way, then it's multiplying by 3.6. Now, remembering the number 3.6 isn't the difficult part. I'm sure you can remember that. But the difficult part might be remembering which way it goes, right? Do you multiply or do you divide? I find myself forgetting that so many times. So the way I've come to remember it is this way. Let's just take this example, right? We've got 2 meters per second, and if we multiply that by 3.6, we're going to get 7.2 kilometers per hour. So kilometers are bigger than meters. Hours are bigger than seconds. And so you're expecting this number to be bigger than this number. That's the way I remember it. So if I get 2 divided by 3.6, I know that that's going to give me a smaller number. And if I'm going to kilometers per hour, that just doesn't make sense. So that's the way I remember whether to multiply or to divide when converting between kilometers per hour and meters per second. The next trap people fall into is thinking that when their calculator tells them 1.45 or time equals 1.45, thinking that that equals 1 hour and 45 minutes. It's a common trap to fall into, but it's wrong. The way we really have to figure this out is, remember, this is a decimal output. This works with the number 100, whereas time works with the number 60 as its base. So what we need to do is convert that into this base 60. So we get that 1 hour, that stays the same, but then we have to separate the 0.45 as the decimal. We multiply that 0.45 by 60 to get the number of minutes, which gives us 27. So when we get 1.45 hours, that actually means 1 hour and 27 minutes. Now, let's move on to the approach that you should be taking to these questions. Number one, ask, what do you need to solve? Is it for speed? Is it for distance? Or is it for time? Because that'll determine which of the 3 formulas that you end up using. Number 2 is to find the missing pieces. So for example, if you're solving for speed, then you need to find distance and you need to find time. The question will give you enough information. You might need to kind of use your maths to figure out those pieces of information, but somewhere or another, you'll be able to find distance and time to find that speed. And that's it. That's the approach to every single one of these questions. So if you're finding this helpful so far, this is just one of the many frameworks and methods that I have for the UCAT. And if you want all of my frameworks in one place, then just click the first link in the description below. Otherwise, let's move on to some worked examples, starting off with this question. So, using the speed, distance, time triangle, pause the video now and have a go at this question. Okay, so let's run through this question together now. So, it's looking for the average speed of the ferry. What do we know? Speed equals distance over time. So, do we have the distance? Yes, we do. That's 105.3. Do we have the time? Yes, we do. It's 3 hours and 28 minutes. But we can't just put 3 hours and 28 minutes into the calculator here. What we need to do is find this time in a decimal format. So if we put 3.28 here, that's how we run into a mistake. What we need to find is 28 minutes out of 60 minutes so that we can find the actual decimal. So you go into the calculator, you do 28 divided by 60, you'll end up with 0.466 recurring. And so what that ends up becoming is, let me just get this out of the way, 3.466 recurring. So you get the 3 hours, you tack on the decimal that you've just calculated on top, and then you make the calculation. And that'll give you around about the answer of C. Fantastic. So let's move on to our next question, starting with this one. Feel free to pause the video now and have a go. All right, so this question is asking about travel. How far do they travel? In other words, it's asking for distance. What's distance? Speed multiplied by time. So do we have the speed? Yes, we do. 30 miles per hour. Do we have the time? Yes, we do. 15 minutes. Now, 15 minutes, you guys should all know, is 1/4 of an hour. So if we get that, 1/4, then we end up getting 30 divided by 4, which ends up giving you 7.5 miles. So C is your answer in this case. So as you'll know, in quantitative reasoning, there's a lot of opportunities for mental maths, and this is also one of those ones. So whenever you're comfortable using mental maths just like this, then I highly encourage you to use it. Let's move on to our next question. So we've got this one. Feel free to pause the video now and have a go. Cool. So what are we looking at here? We're looking at the average speed. Speed equals distance over time. So do we have the distance? 4.5 kilometers away. Do we have the time? It takes 15 minutes. What do we know about 15 minutes? That's 1/4 of an hour. So we can go 4.5 times by 4, and that'll give us our answer. So that's basically like doubling 4.5 twice. Double 4.5, what do you get? 9. Double that, what do you get? You get 18. So your answer here is C. Once again, putting the mental maths to effect. And let's go to another question here. So feel free to pause the video now and have a go at this one. Okay, so let's work through this one. So how far is the total journey in kilometers? So we're looking for how far it is. That's distance. What do we need? Speed and time. Now we've got 2 legs of the journey here, and luckily they've given us both of these. So let's find distance 1. That's speed of 60 multiplied by 20, which is 1/3 of an hour. And then distance 2 is 70 multiplied by 30 minutes, which is half of an hour. That gives us 20, that gives us 35, and we can add these together to give us our answer of 55. We'd select C and move on, except if you did that, then you fell into the trap. Because what this is looking for is the journey in kilometers. And what we've just found is our answer in miles per hour, or in miles. So always keep in mind what value you've got in front of you. So here we're working with miles. So our end result here is going to be in miles. And if you want to convert from miles to kilometers, here we've got that in front of us. So we multiply by 1.609 to give us our answer of 88 kilometers rounded. So our answer here should actually be D. All right, fantastic. Let's move on then to our next question. Okay, feel free to pause the video here, understand what it's about, and then have a go at the question. Alrighty, so let's run through this one. So we can see in front of us, we've got a bit of a diagram that shows the distances between stations, and this is all about the speed and cost of these trains. There's no fine print here for me to look into, which is fantastic. And then here, we've got the table that shows you the train, the speed at which it travels, and then the cost per kilometer. Lovely stuff. So now we're ready to actually read the question. How much does it cost to take this? So now I know I need to look here to travel from C to A. C to A, which is 28 miles. So we can see that our cost here is per kilometer. So we need to convert this 28 miles into kilometers. So what that ends up becoming using this is 44.8 kilometers. Now, with that in mind, we can find the cost because we know the number of kilometers. So we multiply that by 0.75 to give us our answer of 33.6. Fantastic. Cool. Let's move on to our next question. What is the average speed of that train? Feel free to pause the video now and have a go. So, average speed. What is speed? Distance over time. What is the distance between A and B? 42. What's the time? 30 minutes. So that's half. So if we get 42 divided by 0.5, you are going to get the answer of 84 kilometers per hour. So look, guys, I know we're working with pretty simple numbers here, but the point of this is to show you just if you can apply this formula, it'll work every single time. For example, if we were to just change this number up from 30 minutes to, 14 minutes instead, then nothing changes because all we have to do is put whatever this number is in terms of hours and put that into here. How do we figure that out? Well, we get the number 14, we divide it by 60 to get the decimal, which ends up being 0.233. So instead of 0.5, we put 0.233. You're going to get the answer that you need. So the principle remains the same no matter what you do for these speed, distance, time questions. Let's move on to our next question here. So feel free to pause the video now and have a go. Okay, so this is more or less a reasoning question than it is speed, distance, time, where if you've got 50 pounds to use and the cost per kilometer is 0.45 pounds, then the way you calculate how many whole kilometers you could do is by doing 50 divided by the cost. So what you have divided by the cost of each kilometer to give you 111.11, or rounded to the whole kilometers is going to be D. Even if this number gave you 111.99, you'd still round down to 111 because that's the number of whole kilometers you should be going for. Remember, with quantitative reasoning, there's two parts to it. The quantitative side, which is the maths, and then the reasoning side, which is reading the words in front of you and then using that to actually answer the question. So always read the question properly. All right, let's move on to a couple more examples. So feel free to pause the video now and have a go at this question. Alrighty, let's go through this question together now. So on average, what speed, so speed equals distance over time, does the men's 800 meter world record holder swim at? So do we have the distance? Yes, we do. That's 800 meters. And do we have the time? Yes, we do. That's 7 minutes and 32.12 seconds. Now you can see that our answer options here are in kilometers per hour. So you've got two options. Number one is to convert this into kilometers and then this into hours to find the answer. Or because this is already in meters and this is one step away from being in seconds, what we can do is find the meters per second number and then multiply it by 3.6. So let's do that because it's quicker. So we've got 800 divided by, and then now we have to find this in just seconds. The way we do that is, well, what's 7 minutes in seconds? 7 times 60. That gives us 420. So we've got 420 plus the 32.12 seconds. So let's add that on, 32.12. We end up having 800 divided by 452.12. And if we pop that into the calculator, we end up getting 1.76944. So this is in meters per second. Now, if we want to get our answers in kilometers per hour, what do? We multiply by 3.6. So if we do that, we end up getting the answer of 6.369 recurring. The answer is C, 6.37. So hopefully you can see here, if you're comfortable converting between meters per second and kilometers per hour, it can save you a bunch of steps and a bunch of time, especially if you were to convert these individually into kilometers and hour equivalents. Let's move on to our next question. So feel free to pause the video here and have a go. Okay, so let's run through this one together. How much longer does it take longer means we're working with time here. What's time? That is distance over speed. It takes the women's world record holder to complete the 10 kilometers open water than the men's. So do we have the distance? Yes, we do. Do we have the speeds? Yes, we do. So we've got the 5.8 for the men's and the 5.2 for the women's. So what that means is, let's calculate the time for the men's. 10 divided by 5.8. And that's going to give us a time in hours. So 10 divided by 5.8, it's going to give us 1.724 hours. Whereas the time for the women's is going to be 10 divided by 5.2, giving us, 10 divided by 5.2, giving us 1.923. Now, I can see that in my answers, I'm working with minutes and seconds here. So what I'm actually going to do is turn these into minutes. And the way I do that is multiply by 60. Multiply by 60. So this gives me 115.38, and that will give me 103.44. And this way, I can just subtract one from another. So if I do that on the calculator, it'll give me 11.94. So we're working with minutes here, right? That's minutes, that's minutes. So this output is going to be minutes as well. So from there, you can collect your answer of B here. Now, here, there's only one option with 11 minutes, but if it was, really close, like 11 minutes and 53 seconds, 56 seconds, 59 seconds, then how do you pick between them? Well, what we do is we think, okay, what is 0.94 when it comes to a 60-second minute? So we go 0.94 multiplied by 60, and that gives us 56.4. So in reality, it's actually 11 minutes and 56.4 seconds that we're working with here. So B would be your answer. Fantastic. So hopefully this gives you a bit of an insight on how to go about these speed, distance, time questions. Now, I did receive a comment on one of my earlier videos asking about how I go about a question like this, where there's two kind of trains heading towards each other and finding the time that they cross paths. So now that you've had a chance to run through it yourself, here's what I'm going to do to go through this. We're going to look for the time, aren't we? The way we go for time is we look at the distance over the speed. But now you've got kind of two different distances and speeds to work with. Or rather, you've got the same distance and two speeds to work with. How do you do that? So what I'm going to encourage you to do is look at this visually, and I'm going to try my best to draw this out for you. So we've got train A that leaves from Edinburgh, and then we've got train B that leaves from London. Okay, and the distance between them is 650 kilometers. So at 10 a.m., train A departs at 120 kilometers per hour, and then train B departs at 11 a.m. So the difference between those two is an hour. In other words, train A has traveled for 1 hour before train B even departs. The reason that's important is because it'll change the amount of distance that both of them cover at once. How do we know how much distance? Well, if they traveled for 1 hour, if train A traveled for 1 hour and its speed is 120 kilometers per hour, then it traveled 120 kilometers. So let's do that here. 120 kilometers. Now, we are at 11 o'clock by the time train A has traveled this much. Now, at 11 o'clock, B departs London. And so what ends up happening is not only is A going this way, B is also going this way. And now the way that I want you to look at this is think about how much distance do we have remaining and what is the cumulative speed of the two trains. So how much distance do we have remaining from the 650? So if we subtract the 120 that A has already traveled, we end up getting 530, which I'm just going to draw out in blue here. So 530. And now if A is going 120 kilometers per hour and B is going 130 kilometers per hour, then after every hour, they are 250 kilometers closer to one another. How do we get that? We just add the speeds. So with that in mind, we can find the time that it takes. So if time equals distance over speed, then we have distance, 530 kilometers left, over speed. They are 250 kilometers closer to one another after every hour. So that ends up giving us 2.12 hours. Now, what is 0.12 in hours? That is 0.12 times 60, giving us 7.2 minutes. And so what this means is we've got 2 hours and 7.2 minutes before, the trains finally cross paths. Now, we actually have to answer the question, at what time do the two trains cross the paths? So we know that this is 2 hours and 7.2 minutes from 11 o'clock, which is when B started. That's when we started this calculation using the number 5:30. And so the answer becomes when we add 2 hours and 7.2 minutes to 11 o'clock, which ends up being our answer of D in this case. So hopefully this example illustrates to you how to go about a more complicated speed, distance, time question like this. But as you can see, the principles always remain the same. So this has just been a handful of questions that we've gone through for speed, distance, time. And if you want to do more questions, but you don't already have a question platform, then you can use the code Farhan for 10% off MedEntry. Otherwise, let's go through some common traps that people fall into when it comes to speed, distance, time questions. Number one is forgetting unit conversion, like kilometers per hour to miles per hour. Number two is interpreting the calculated time for the real time. We know that 1.45 in the calculator does not mean 1 hour 45. You need to multiply the 0.45 by 60 to get the minutes equivalent. And number three is overcomplicating the question. You're going to start with what you need to find. Identify that and then find the missing variable so that you can solve for the question. So here's your do's and don'ts. Do draw the speed, distance, time triangle out before you start your QR section, just so it's top of mind. Do start with what variable do I need to solve for? And do watch out for unit conversions. Don't misinterpret your calculator outputs of time. Don't start calculating before you know what you're looking for. And don't pick an option just because it matches your calculator output. You have to check the units. They always like to trap students by giving you an option that is correct, but with the wrong units. So here's your next steps. For the next 20 speed, distance, time questions, I want you to apply the speed, distance, time triangle and see if it helps you answer the questions not only quicker, but more accurately as well.